Oh, so we've made it. Last video, last video. Okay, here we go, here we go. Thanks for sticking with me if you went through, especially if you did the full block, all of that. Good for you, good for you. So yeah, let's go through this. Like I said, I'm not totally sure if this is still in, but it did used to be in, and it's a good way just to challenge yourself a little bit. So lots of words. Let's have a quick read. So a yacht, impossible to say another impossible to spell word yacht. I mean, so sails from a harbour H to point C, and then to point D shown below. So it goes from here at the harbour, then it goes up to point D, and then down here to point C. Oh, sorry, it goes from harbour to point C, then to point D. Sorry. So that's the distance. That dotted line must represent the distance of it from the harbour. Then, so C is 50, and it's due east of H. Okay, so that's already on there. The due east just means that that angle in there is 90 degrees. That's all that means. And it's kind of inferred from looking at it because you can see it's a nice straight line. So I won't write that. And just as a quick note, just to go through the idea of bearings, you always take your bearings from the north. So if you're due east of someone, you would go all the way around to here. That would be your bearing of 90 degrees. Your bearing always goes clockwise from north. So a bearing of 200 degrees, take it all the way around there from the north 200 degrees. So you're always facing north and turning clockwise for your bearings. So it's just worth remembering that. D is on a bearing of 40 degrees from C. So 40 degrees from C, so let's zoom in here. What that means is that this little angle here is 40 degrees. Write that somewhere where you can actually see it. That is 40 degrees because we go from north and we go all the way around to the line we're looking for, and that's our bearing. So that's 40. And that's interesting. So if that's 40 and we know that this one was 90, that makes that 90 as well. So now I know this entire angle is going to be 130 degrees. I'm just going to write down 130 degrees for that full angle in there, 130. So, and the 79 is already, D is on a bearing of that from C, and the 79 kilometers from H. The 79 kilometers from H. And that is worded particularly well, to be honest. I'm going to read that again. So D is on a bearing of 40 degrees from C. Okay. Oh, and D is 79 degrees from H. Yeah, I think if it wasn't drawn out, I probably would have got 79 down there. But anyway, yeah, I would have just said the D again. But anyway, calculate the size of angle CDH. So CDH, it's this angle up here that I'm trying to find. So we know it's angle trigonometry because we've got a non-right angle triangle. So we're going to use the sine of the cosine rule. But are we going to use sine or cosine rule? Well, I know one length. I know two lengths. I do not know a third length. I'm not trying to find that third length. So it has to be the sine rule. So let's start labeling stuff up. Okay, if I know this length, I know this angle, that's fantastic. And I want to find this angle up here, and I know the length opposite, fantastic. So that makes my life quite easy. All I'm saying is, right, sine of angle D opposite length D, and I'll call that sine of angle C, and that's opposite length C. Now you could call it AB, doesn't matter, I'm just trying to keep a wee bit of terminology for the question. So sine of angle D divided by length D, which is 50, and that's equal to sine of 130. So we've done the hard bit. Actually, that's the hardest bit, is knowing this angle in here is 130, and the length opposite is 79. Again, if you didn't know that angle in there, you would just say, well, look, it's definitely got to be the sine rule because I know two sides. Oh, I really need to know this angle in here. You would just make something up. That's absolutely fine. And then look, there's still 3 marks to be had. So sine of angle D is going to be equal to 50 times sine of 130 divided by 79. So let's do that on our calculators. So I've got that as 0.484. Well, sine of D is equal to that. So then D is going to be the shift sine or the sine inverse of 0.484, which is equal to, so I'll do shift sine of 0.484 to give me, I'm just going to round that and call that 30, oh not 30, 29, sorry, 29 degrees. Or, you know what, I should probably practice as I preach. Write out what you get, and then I'm just going to round that off to 29 degrees. I didn't use the answer button on here because I'm using the app on my phone, which use a calculator. I've left my calculator at school because it's holidays, so get used to using your calculator. But you could have put the full number. So I guess something just slightly different if you've left the full number in, which would be better. Okay. So 29 degrees, hurrah. Now it says, hence calculate the bearing on which the yacht must sail to return directly to harbour. Great question. So it's saying, right, what bearing? So I'm up here. I'll do this in orange. I'm up here. What bearing will take me to the harbour? So it's like all the way around here. That's your bearing. So that's the bearing to that line. So you go all the way around to here. That would be the bearing to harbour. So how would I work out that full angle in there? Well, I'm going to zoom out a bit. This is where it gets a little bit interesting. So I'll move this working down. I'll move it over a little bit. Put it over here just now. So what do we know? Well, I'll just undo that just now. We know, obviously, that angle we've just worked out. So we know that that's 29 degrees in here. So I know that's 29 degrees. I also know that from north to south, that's 180 degrees. So it's actually just this little angle in here. The question's really saying, what's that angle in there? How do you get that? And this is great. This is where you have to use your north lines. Use this north line here and this north line here as Z angles. So what you've actually got here with this north line and this angle, and then down here is a Z shape. So that 40 we worked out before, that actually pops up in there. It's 40 degrees. So the bearing is going to be equal to 180 degrees plus 29 degrees plus 40 degrees. There's a 9, there's 12, 13, 14, and 2. So it's 249 degrees. That's the angle all the way from north, all the way around there. Now that's a 2-mark question. I'm guessing, again, if you weren't totally sure, if you started doing some of your working, you would get, I've not seen the marking scheme, but you would get some marks for knowing some of it. Like if you knew the 180 and the 29, and that might be a mark, and then knowing this would be another mark. So watch out for those Z angles using the north lines as parallel lines. Yeah, that's a great question. That's about as hard as they can make bearings, I would say. Let's have a look at this one. We've got 2 minutes, so just have a wee read. So excellent question, excellent question. So first thing we'll do is think about the bearings. Okay, so Gordon walks at a bearing of 45 degrees. So I know that angle in here is 45 degrees, so I've used that bit there. Brian walks on a bearing of 100 degrees. So this whole bit here is 100. So the bit in the middle just here is going to be 55 degrees because 100 to take away 45 would be 55. So that's me worked out 2 angles already. That's looking quite good. I've got that. I'm just going to leave this just now. And how far would it be after 2 hours? So we're asking for a length. We're asking for this distance in here, x. Okay, so how far would it be after 2 hours? All right, well, let's look at Gordon. He walks 4.4 kilometers an hour. So after 2 hours, he's gone 8.8, hasn't he? He's gone 8.8 kilometers. That's the distance of that one. Brian, 4.8 times 2. 4.8 times 2, 16, 9, 9.6. Okay, that's how tired I'm getting. I have to do a little sum for that. 9.6 just to, it's been a long day. 9.6 kilometers. So am I going to use sine rule or am I going to use cosine rule? Well, I've got 1, 2, and 3 sides. So it's going to be a cosine rule, isn't it? So I'll get the cosine rule up. Yeah, just conscious of time, so I'm trying to save a bit of time there. So then x squared is going to be equal to 8.8 squared plus 9.6 squared. Doesn't matter what they are. Take away 2 times 8.8 times 9.6 times cos of 55 degrees. So that's going to give you x squared is equal to 72.688. And just to get x on its own, I'll take the square root to give me 8.5 kilometers. So 10 seconds left on the video. Yeah, the only thing here, I quite like the idea to work out the length using speed distance time, so 2 times the length, and just understanding what your bearings are. So I hope that was helpful, and yeah, best of luck.